Hello, welcome to my channel. In this video, we are going to take a look at the part 2 of the previous problem that we looked at. So the problem we are going to be looking at is in this form. So in our previous video, we found the least force F acting at this point along this axis through the center of this wheel. But this time around, we are going to be looking at the force, the least force acting at this point. So let's look at the problem attached to this problem diagram. We have what is the least force needed to pull the wheel onto the curb successfully. So let's take a look at some diagrams that are already hidden. So initially we need to find the distance from here to here. We know that the distance from here to here is the radius. From here to here is h. So the distance from here to here will be r minus h. Also, in our previous video, we were able to find the distance from here to here, right? Because it will be needed in this problem. We're able to find the distance from here to here. Then, since the force is acting at this point, so we need to trace a line that is a line from this point to this point, and that is given as x. Okay, to solve this problem, we need to find this value x, the distance x. And to find this distance x, we can see that it traces a triangle. Since we know from here to here, that is r plus h, and we also know this one from our previous video, we can get this one using Pythagoras theorem. So we have this part, which is this one here, squared, plus this part here, which is this part, equal to then the square root of x. So if we make our x the subject formula, we have something of this form. If we resimplify, then we have this next line followed by our x equal to square root of this. So x from this point to this point is this expression, right? So let's find the torque, the clockwise torque, that is the force here times this perpendicular distance times the angle it makes with this particular line. So, and that is given us the clockwise torque is equal to fx sine theta. So let's look for the value of sine theta. Remember, the angle theta here is from this point to this point. And if we notice, this angle here is equal to this angle here. And the angle here, if you find the sine theta of it, it is equal to opposites all over hypotenuse. And that's giving us 2r minus h all over x. 2r minus h all over x. This is our 2r minus h all over x. And our x cancels x. We have the clockwise torque equal to force times 2r minus h. So let's look at the anti-clockwise torque, which is as a result of the weight of this wheel acting from this center down times this particular radius times sine theta, and that's giving us TA, anti-clockwise torque, equal to mg, which is the weight pulling down, times this r, which is this r to this point of fulcrum, times sine theta. And our sine theta is this angle here, because this is the weight is acting on this line here. So the angle here is equal to this. So to find this angle, we need to find opposite all over hypotenuse. So this particular distance is already known, which is this expression, all over this r, and we have it as mgr, this expression, which is this inner expression, all over r. So r cancels r, and we have our anticlockwise torque equal to this expression. So at equilibrium, we notice that the TA, that's tau A anticlockwise, and that of the clockwise torque must be equal at equilibrium. So we have TC equal to TA. Okay, so the next thing we do is to bring out the expression for the clockwise and the anti-clockwise, which is this. So make F the subject formula, we have this expression. Okay, so if M is given, if the value of M is given, the value of R is given, the value of H, just like the previous video, we have something of this form: M equal to 1.5, R equal to 0.62, H equal to this. What will be the value of F? So if we plug in all the parameters, we get our F to be equal to 4.35. So this one is the least force at the top of the wheel or a little bit above it, right? Then if you compare with the previous video, which act along the center through, along the axis through the center of the wheel, we have F equal to 5.79. That is force along the axis through the center of the wheel. So you notice that the force at the top of the wheel, the least force is lesser, far lesser than that of the force at the axis, through the axis at the center of the wheel. So we can see that this one is smaller than this, right? I hope this helps. Please like, share, and follow. Thank you.